Welcome to a sim code. This is a Python implementation of the Feistel cipher, a symmetric structure used in block ciphers. We start by importing the hashlib library for cryptographic hash functions. The hashlib library provides SHA-256, which we'll use in our round function. Next, we define the Feistel round function. This function takes the left and right halves of the block and a key as input. Inside the Feistel round, we define a helper function called round_function. The round function combines the data and key as strings, then encodes them into bytes. It hashes the combined data using SHA-256 and converts the result to an integer. The new right half is computed by XORing the left half with the round function output. The new left half is simply the original right half. The function returns the updated left and right halves. Now, let's define the encryption function. This function encrypts a block of data using the Feistel cipher. The block is split into two 32-bit halves. The left half is the higher 32 bits. The right half is the lower 32 bits of the block. We perform the Feistel rounds for the specified number of rounds. In each round, we update the left and right halves using the Feistel round function. After all rounds, the two halves are combined to form the ciphertext. The ciphertext is returned as the final encrypted result. Next, we define the decryption function. Decryption works similarly to encryption, but in reverse order. The block is split into two halves again. The right half is extracted from the lower 32 bits. We perform the Feistel rounds in reverse order using the keys. Each round updates the left and right halves. The two halves are combined to form the decrypted plaintext. The plaintext is returned as the final decrypted result. Finally, let's add an example usage of the Feistel cipher. This block runs when the script is executed directly. We define a 64-bit plaintext block for encryption. We define a list of keys, one for each round. The number of rounds is equal to the number of keys. We encrypt the plaintext block using the Feistel cipher. The ciphertext is printed in hexadecimal format. We decrypt the ciphertext to get back the original plaintext. The decrypted plaintext is printed in hexadecimal format.